Welcome to Digital Electronics, Lecture 1, Part 2. We will discuss AND operation. An application of typical AND operation is cloth dryer. It will dry clothes only if condition 1 is the timer is set above 0 and condition 2 is the door is locked. If both of the condition is satisfied, then dryer will dry the cloth. Let's assign A to represent timer is set, B to represent door is closed, and X can represent heater and motor are on. The dryer will only work if both conditions are true, otherwise it will not perform its function. This is a typical symbol for AND operation, AND gate. So 2 input AND gate, it could be multiple input AND gate as well. So for 2 input, as we know, 2 to the power 2, 4 combination. So in truth table, we have 0, 0, 0, 1, 1, 0, 1, 4 combination. This is our input side. Output side is x. X equals a dot b. So this is AND sign, a dot b, or a and b. So here you can see the output is 0 for all the combination except when both of the input is high. If both of the input is high, then output is high, otherwise output is low. So this is the typical equation for AND operation, and the dot sign stands for Boolean AND operation. So timing diagram. So you can locate here T0 at T0 AV both 0 T0. See if both of them are high, it is high. So it is very clear if you look at here. So this one high, this one high. If both of them for this region will be high. Again, this region, the shaded region, this region will be high. So these two shaded region is high because here input and input A and B both is high, input A and B both is high. For all other combination, the output is low. Let's say the output is low. I'm not going into detail because I think you will understand it from the previous concept. So, and this is the typical AND gate. So timing diagram, I think you should also determine the timing diagram here. I suggest you try it by yourself. If not, then we will discuss it in the class. Then come to the NOT operation. The NOT operation is unlike the OR and AND operation because it can be performed on a single input variable. For example, if the variable is A is subjective to the NOT operation, the result X can be expressed as X equals A bar. The over bar represents the NOT operation. This expression is read as X equals not A or X equals inverse of A. Say you have input A and output will be A bar, which means you have input 0, output will be 0 bar means 1. Input 1, output will be 1 bar means 0, the inverse of input, inverse of input. Summary of Boolean operation. The rules for OR and NOT operation may be summarized as follows. If you look at the OR operation, you can see if we have 0 or 0 or 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 0. It's not really plus, it is OR. So you can see it is 0 when both of the input is 0. Both of the input is 0, the output is 0, otherwise it is high. And is the reverse. If both of the 0 0, if both of the 1, then 1, otherwise 0. Just reverse of this one, inverse of this one. So 0 dot 0 0, 0 dot 1 0, 1 dot 0 0, 1 dot 1 1, and not is just inverse, 0 1 1 and 0. This is very important concept you need to understand and remember because it will be needed throughout the course. NOR gate. it is same as the OR gate, except that it has a small circle on the output. So it is this one. The small circle represents inversion operation. Thus, the NOR gate output is like an OR gate followed by an inverter. So just look at here. So this is our OR gate. If we connect it with inverter, that will be NOR gate. Just look at here. We have two input NOR gate. This is the truth table. So for OR gate, we have, if both of the input is 0, the output will be 0. Otherwise, it will be high. So if you make the inversion of this input, so 0 becomes 1 and all 1 becomes 0. So if you invert it, then it will be NOR gate. So the mathematical equation is A plus B, or A or B for OR gate, and for NOR gate A plus B bar, which is NOR gate. So this is a timing diagram. I think it's easier for you now to draw the output. So this is the circuit. So you have given A and B, you need to determine X. So A and B is given. So if you know the truth table, then you should know how to draw this one. So I suggest you pause your video now and try to draw it by yourself, and later on check with the result. If you find any difficulty, we'll discuss it in the lecture. It says determine the Boolean expression for a 3-input NOR gate followed by an inverter. So you have A, B, and C, which with inverters, so which can be written as A plus B plus C inverted. If you do again inversion, then it will become A, B, C. NAND gate. So this is the inverse of AND gate. So it is same as the AND gate, except for the small circle on its output. So this is the small circle. So this is my AND gate. If you connect it with inverter, it will be NAND gate. And the same thing here. So A and B, this is the AND gate output. So if you do the inversion, so all 0 becomes 1, 1 becomes 0, then it will be NAND gate. So here, if both of the input is high, then output is high. And for NAND gate, if both of the input is high, then output is low, otherwise high. So this is the timing diagram. It's very simple. If you understand the truth table, then you can determine, you have given the A and B, you need to determine the X. Again, if you find any difficulty, we will discuss it in the class. Now implement the logic circuit that has the expression using only NOR and NAND gate. So here, this is our NOR gate and this is our NAND gate. So C and D is input C and D bar, then C and D bar and BA. So this is AND gate. So A and B will be multiplied, and that will be multiplied with C plus D. This one, as we have inverter. So for this inverter, this one, for this one, inverter, this one. The term C plus D bar is the expression of the output of a NOR gate. The term is AND with A and B, and the circuit is inverted. This is, of course, the NAND operation. So this circuit we implemented using NOR and NAND gate. XOR gate. So this is the typical symbol of XOR gate. So OR gate, but here there is another curve sign here, you can see. So this is called XOR. The truth table is like this. If your both of the input is 0, both of the input is same, the output is 0, like 0 0, both of the input is same, or 1 1, both of the input is same, the output is 0 0, otherwise it will be high. So this plus sign, this is called XOR sign actually. A XOR V. This read as A XOR V, and this is my input A, this is my input V. We need to determine output. So if 0 0, output is 0, output is 0. 0 1, 0 1, output is 1. Then 1 0, so 1 0, output is high 1. 1 1, 1 1, output is 0, something like that. This is XOR gate. XNOR gate. So this is the symbol XNOR gate. So OR gate, then this curve, then this inverter. So here you have, if both of the input is same, the output will be high, otherwise output will be low. This is A XOR B bar. This is called XNOR. The waveform, if you look at, so 0 0 0 0 output high, 0 1 0 1 output low, 1 0 output low, 1 1 output high, something like that. Now evaluate logic output. To evaluate logic output, like you have given this um, expressions, so like x equals a prime dot b dot c a plus d bar. So you need to evaluate the expression. How we can do it? Or this one. So to perform that function, first perform all inversion of single term. Say like a prime. So you need to do the inversion of this one. So you have given a equals 0. So put a equals 0, then prime, it becomes 1. So then perform all operation within parentheses. So you have parentheses a plus d prime. So here a0 d1, put the values and prime. So do the operation 0 and 1. So 0 and 1 is 0 or 1 is 1. Then 1 prime is 0. So this part is done. Second one. The third one is perform an AND operation before an OR operation unless parentheses indicate otherwise. So here you need to perform AND operation first unless parentheses indicate otherwise. So if you do the AND operation, then it becomes, as you have 0, so it becomes 0. So similar thing should be for this one. So I suggest you pause the video now and try to find for this expression what's the output. Remember, you have given A, B, C, D, E values. Just need to put the values here. Check the concept. Given the following logic diagram, which is the correct logic expression for F? So you have given this AND gate with inverter and then XOR gate. It's not really OR XOR. So what should be the output? So I suggest you try to find the solution. We'll check it in the lecture session. Implementing circuit from Boolean expression. When the operation of a circuit is defined by a Boolean expression, we can draw a logic circuit diagram directly from the expression. For example, if we needed a circuit that was defined as x equals a dot b dot c, we would immediately know that all that was needed as a 3-input AND gate. If we needed a circuit that was defined at x equals a plus b prime or bar, we would use a 2-input OR gate with an inverter on one of the inputs. The same reasoning used for this simple case can be extended to more complex circuits. In the next lecture, we will implement circuits from Boolean expression for a couple of complicated circuits. Thank you.